In this video, you will learn about bagging and boosting, two types of machine learning methods known as ensemble learning. Let's get started. Ensemble learning is based on the principle that many predictors are better than one predictor. Both bagging and boosting methods accordingly build multiple models and combine their predictors for better performance. Bagging stands for bootstrap aggregating. You start bagging by generating a bunch of random samples with replacement from your dataset. Then you train a model for each of these samples, resulting in many models. Finally, you combine the predicted outcomes from all these models. If the target variable is categorical, you take the majority vote of the predicted class. If the numerical, then you calculate the average of the predictions. A random forest is an example of a bagging algorithm. It consists of a collection of decision trees, introducing additional randomness during the training at each tree. Only a random subset of all available features is visible at each tree node, making a random forest robust against overfitting. Unlike bagging, where all models are trained in parallel, boosting trains models sequentially. You start with your first model, which likely produces some prediction errors. The next model will focus on those data points that resulted in errors, giving more weight to them. This process continues with each subsequent model, focusing on the errors from the previous model. Gradient boosted trees is an example of a boosting algorithm. At each step, a shallow decision tree, known as a weak learner, is trained on the data, emphasizing errors from the previous step. This tree is added to the current model to update it. The process is repeated typically for 50 to 100 iterations to generate the final model. More iterations may lead to overfitting. The main difference between bagging and boosting lies in the order of model application. Bagging applies models in parallel, while boosting applies them sequentially. This results in heavy computational load and memory usage for bagging, but lighter memory and CPU usage during sequential training sessions of boosting. The ensemble learning methods described in this video are available in the KNIME Analytics platform. Nodes are available for both classification and regression analysis. In this video, you have learned how bagging and boosting work as ensemble learning methods. Multiple models are trained in parallel in bagging. Models are trained sequentially in boosting, and how KNIME provides nodes for implementing these ensemble learning methods.